Welcome to MyProjectBazaar.com. Now we discuss about the product for low power programmable pseudo random pattern generation with test compression capabilities. Next we see the abstract for the product. Although over the next years the primary objective of manufacturing test will remain essential the same to ensure the reliable and high quality semiconductor product conditions, and consequently also the test solution may undergo the significant evaluations. This paper describes a low power programmable generator capable of producing pseudo random pattern test patterns with desired toggling level and enhanced fault coverage gradient compared with best to date built-in self-test based pseudo random pattern test pattern generators. It is compared with the linear finite state machines, a linear feedback shift register and ring generator driving a appropriate phase shifter, and it comes a number of features allowing this device to produce binary sequence with pre-select toggling activity. We introduce a method to automatically select several controls of the generator, offering easy and precise tuning. The same technique is subsequently employed to deterministically guide by generator towards test sequence with improved fault coverage. The pattern count ratio. Furthermore, this paper proposed the low power test compression method that allows shaping the test power envelope the fully predictable and accurable and flexible fashion of adapting in pre-select toggling based logic based infrastructure. The proposed hybrid scheme effectively combined the test compression to deliver high quality test. This process mainly focused by architecture wise logical based architecture methodology. This method to improve the circuit performance analysis and quality level. Next we see the flow diagram for the product. First, the test control function create the two set of controlling functions. One is reset and another one is clock function. The clock function to activate the overall process and reset to reset the all values in our architecture process. Then go to the test pattern generation. This pattern mainly based on NED based pseudo random pattern generating architecture. This architecture to create the test patterns for overall architecture process. Then go to the CUT with DFT section. The CUT means circuit under test. DFT means design for testability. This section to produce the which circuit to be tested. This tested circuit to be presented in CUT architecture. Our process to example for 8x8 bit multiplayer architecture. This 8x8 bit multiplayer to generate the input test patterns automatically. So we adapt the automatic test pattern generation for 8x8 bit multiplayer. This multiplayer to produce the 16-bit output results. The output results are passed to the next processing for test output result function. This result function every clock to be activated and to generate the output results. Then go to the MISR functions. These functions used to multiple in signature register. This function to create the signature based on our circuit under test output results. These results to generate the signatures. And another one process is row memory architecture. This architecture mainly used to store the expected results. These expected results to be controlled by clock and reset function. Then the clock function to be activated, the row memory to be generate the golden signature. The output response comparator is compared with golden signature and record present signature. Then to compare the signature and identify the signature variations. The signature is same to create no fault to be detected. The signature is to be wrong. The fault detecting process to be collect the which fault to be identification. Then the fault status level and performance analysis for total overall testing architecture. This is our final flow process for overall testing architecture. Next we see the final output for the product. Our product was developed in Xilinx 14.2 software, and this product was developed in VHDL language. This is our process. Then go to the simulation process. Then to run the simulate behavioral model. The simulate behavioral model was completed. Then to create the iSim project navigator. This project navigator file is used to simulate our overall process. Our simulation process is to when the input and to automatically get the output for the overall 8x8-bit architecture test results. We apply the reset and clocking function for our overall process. Initial reset function, we apply the initial bit allocations. Then to remove the reset functions and to apply the clocking sequence one by one, we generate the test input patterns and to create the output pattern results. This is our process. These are the overall multiplication results for every clocking sequence. This is our fault identification process. This present is 0. There are no fault to be present here. If the fault is occurred, this present is 1. This is our sequence process. First sequence and 10th and next sequence process for overall architecture. This is our multiplying results. This is our overall simulation process for BIST architecture. Then go to the implementation process. This implementation process to create the RTL schematic diagram. This RTL diagram to represent the what are the logical presented in our overall architecture process. Then technological diagram. The technology diagram to present the what are the input and output buffers and clock sequence to be presented in overall architecture process. Then add and create the schematic process. Then to create the overall process. This is our phase shifter circuit. This is our multiplying sign register. This is our ROM process and the output response comparator. Then the admir process. This is our overall architecture for multiplayer architecture. Then comparing results, performance analysis. This is our technological diagram. This is our overall technological diagrammatic representation for overall process. Then go to the design summary and to create the synthesis report results for what are the timing and area implementation for overall processing results. This is our overall process for BIST architecture results.